Hi everyone, I'm Shahad Karabeti. I'll be presenting today with Omar Mohi, our final milestone of the project. Our project is image captioning, which is mainly converting an image to a text describing it. As you can see in this figure, the dog image is converted to a sentence describing this image using captioning model.
Okay, so in this slide we have the diagram for our model. The model uh, consists of three major parts. The first one is the clip, which is an encoder. So this is a pre-trained encoder that they used called clip, and there's a language model which is called GPT-2. And finally, the our model itself, which is the mapping between the clip encoder and the language model. This is the one we train.
These are our hyperparameters. We used cross entropy loss. Also, we used Adam as an optimizer. We used a batch size of 40 and 8 layers in transformer. Our proposed solution is to study the effects of data augmentation. For example, we tried to change the brightness of the image and to rotate the image to see how this will affect the result of the text resulting of the image.
Okay, so for the results, as as the model was training for each epoch, we graphed the loss for each epoch. The results here shown are for the ResNet 50 times 4 model. In fact, we trained the model three times, once for different model types. The results shown below for the loss versus epoch are for the ResNet 50 times 4 model type. Okay, so for the results in evaluation based on blue metric score, uh, these are the results for ResNet 50 times 4, VIT-B, and ResNet 50. Yeah, we found the original model that we found online. The model weights were for the ResNet 50 times 4 from the paper. We compared these results with our VIT-B and our ResNet 50 times 4 and our ResNet 50 models. And for reference, we trained the ResNet 50 and VIT-B models for 15 epochs and trained the ResNet 50 times 4 for 25 epochs.
These are the results in a table. We compared the scores of each of the models. And as you can see, the ResNet is the best out of the four other models because it has the highest score in almost all the scores. Also, these are the results, the sentences that are generated after we had these images as input. For example, the first image, which is an image of the house, the original model stated that a white house with a fountain in front of it. ResNet 50, the output was a large house sitting out in the grass in front of the farmhouse. And for ResNet 50 times 4, the output was a post house with a fire alarm and a bench. And for VIT-B 32, the output was a gallery of pictures in a brookish lake with a brookish brothel. And for the dog image, the original model was a brown and a white dog standing in the field. And for ResNet 50, a dog sitting on the grass in a photo. And for ResNet 50 times 4, The output was a photo of a dog standing in the grass with a purple collar behind him. And for VIT B32, the output was a white blanket with a picture of a baby in the picture.
Okay, so in conclusion, we found that the ResNet 50 model had the best blue score on the validation dataset, which was even better than the original ResNet 50 times 4 model that we found in the paper. But note that the validation dataset that we used was the original validation dataset from Coco, but after applying the augmentation, which was brightening the images and darkening them and also having some rotations. So that was the validation dataset that we used. And also we found that the VIT-B model was significantly worse than any other model, which we did not know why this happened. Uh, so in the future, we think it's possible to it would be better to train the ResNet model for more epochs, as we uh, did not train it enough, as we saw that the loss was still decreasing and it hadn't stopped decreasing. Also, it's possible to find different model types that are better, such as ResNet 101, which we did not try. Here you can find the contribution of the work. Thank you.